This is January 05. Question 5. Define in terms of energy the electromotive force of a battery. So again, this is the third time we've written this now in these podcasts. Energy changed to electrical energy per unit charge passing through the battery. And then the next question asks you what is meant by internal resistance. And the internal resistance is the opposition to current flow. And it comes from inside the battery. So that's important that you get that word in there, inside the battery. Part B, figure 5.1 shows a resistor of resistance R connected to a battery of EMF E and internal resistance R. The current in the circuit is I, capital I. Write down an equation connecting the EMF of the battery, the potential difference between its terminals X and Y, and use the symbols E, I, R and V. So that's just the equation that you would have learnt. You know that E is equal to the current times R plus R. So R plus R are just internal resistance and the external resistance. But we're not being asked to leave R in our equation, so we have to multiply that out as IR plus I, capital R, and then change this into V. So E is equal to IR plus V. And leave it like that because those are the symbols you're being asked for in your E, I, R and V. The next part of the question, the EMF of the battery is 1.5 volts. The circuit current is 0.5 amps and the external resistor has a resistance of 2.94 ohms. Calculate the internal resistance of the battery. So we're going to use the equation we had a minute ago, V plus I small r. We know the EMF is 1.5. We know the voltage in the we'll know that the current in the circuit is 0.5. We know our external resistance is 2.94, and we don't know our small internal resistance. Well, it's not necessarily smaller. We don't know the size of it. So when you multiply everything out there, in fact, we'll not multiply. We'll just divide by 0.5. So 1.5 divided by 0.5. is equal to 2.94 plus R. And when you bring this across, then R comes out there to be 0.06 ohms. Calculate the power dissipated in the internal resistance of the battery. Just use P is equal to I squared R, small r. And then we know that the current flowing through is 0.5 and you have to square it. And we know R is 0.06 ohms. And therefore the answer comes out to be 0.015 watts. And you would get an error carried forward from the question above if you hadn't that answer. Suggest a reason why the power dissipated in the internal resistance of the battery is sometimes described as a rate of energy loss. And the reason is because, well, first of all, power is energy over time, so that's the rate of energy being changed or being lost. So that gives you the rate idea, but also then the energy created in the, I shouldn't say the word created, but the energy transferred inside the battery is unusable heat. So it's not useful and could be described as being lost. Just write is lost. And that's enough to get you your mark there.